Shroud of Turin is this amazing relic. At bottom, it's a piece of cloth.
The image on the shroud is sometimes very hard to see. It just seems to be almost...
He was wrapped in linen, and then his body was put in the tomb.
According to the legend,
the shroud may actually be around 2,000 years old.
with the body of Jesus.
For nearly 2,000 years, this cloth has refused to give up its secret. Empires rose. Technology advanced. Science explained the world. And yet this single piece of linen still stands in defiance. Now, for the first time, artificial intelligence has looked beneath the surface. And what it found may have changed the mystery forever. For nearly 2,000 years, this cloth has refused to give up its secret. Empires collapsed. Civilizations advanced. Science learned to read the code of life itself. And yet, this single piece of linen still stands in defiance. The Shroud of Turin, a 14-foot-long burial cloth that carries the faint image of a crucified man. To some, it is the most sacred relic on Earth. To others, it is history's greatest fraud. For decades, the debate seemed settled. In 1988, 3 of the world's most respected laboratories tested the cloth: Oxford, Zurich, Arizona. Their conclusion was clear. The fabric dated to the Middle Ages. Case closed. Or so it seemed. Because from the very beginning, the shroud never behaved like an ordinary object. It didn't act like a painting. It didn't act like a stain. And it didn't act like anything science had ever seen before. When the first photographs were taken in the 19th century, something impossible happened. The photographic negative revealed a perfect, lifelike image, clearer than the cloth itself. In other words, the image on the shroud was already a negative. Centuries before photography existed, that alone should not have been possible. But it was only the beginning. Scientists soon discovered the image wasn't soaked into the fabric. It didn't bleed. It didn't spread. The coloration existed only on the outermost surface of the fibers, so thin it measured just a few hundred nanometers deep. That's thinner than smoke residue, thinner than a fingerprint, far thinner than any known paint, dye, or pigment. No brush strokes, no direction, no material applied. It was as if the cloth had been touched by something that changed it, without ever touching it at all. For decades, researchers tried to recreate it. Heat, chemicals, rubbings, sculptures. Some methods produced faint images, others produced shallow discoloration, but none reproduced everything. Not the depth, not the precision, and certainly not what came next. Because when scientists looked closer, they realized the image wasn't flat at all. Hidden inside the light and dark areas was information, distance information. And that discovery would force a question no one was ready to answer. If this image wasn't painted, and it wasn't pressed, then how was it formed? And more importantly, what kind of process leaves behind 3-dimensional data on a 2-dimensional cloth? What scientists uncovered next wasn't artistic skill. It was something that behaved like a measurement. In the 1970s, a group of researchers made a decision that would change the entire debate. Instead of studying the shroud as art, they treated it like data. At the United States Air Force Academy, scientists took a high-contrast photograph of the shroud and fed it into a machine originally designed for one purpose: to read the surface of distant planets. The device was called a VP-8 image analyzer. NASA engineers had built it to turn variations of light and dark into 3-dimensional terrain maps. On normal photographs, the result was chaos. Faces warped, shapes collapsed, depth turned into noise. But when the image of the shroud was processed, something unprecedented happened. A perfectly proportioned three-dimensional human form emerged, not distorted, not exaggerated, not guessed. The darker areas of the image corresponded exactly to parts of the body that would have been closest to the cloth. The tip of the nose, the brow, the hands, the feet. Lighter areas aligned with parts farther away. For the first time, scientists realized the shroud did not simulate depth. It contained it. This wasn't how paintings worked. Artists fake depth using shading and perspective. But the shroud didn't rely on visual tricks. Its brightness followed a strict rule, a direct mathematical relationship between image intensity and distance. In simple terms, the cloth behaved like it had measured space. That discovery split the scientific world in two. Skeptics argued it was coincidence, that the mind was seeing patterns where none existed. But engineers pushed back. They tested paintings, photographs, drawings, even modern digital images. None produced stable three-dimensional results. Only the shroud did. And that raised an uncomfortable problem. If a medieval artist created this image, they would have needed knowledge of geometry, optics, and spatial encoding that would not exist for centuries. They would have needed to control image intensity down to microscopic precision across an entire human body without leaving a single brushstroke. The odds were already collapsing. But then another detail emerged, one that made the idea of forgery even harder to defend. The image did not wrap around the sides of the body. If the cloth had been pressed or draped, the face would have distorted. The image would have curved. Instead, it projected straight outward, as if the body and cloth were separated by a small, uniform gap. That isn't how contact works, and it isn't how art works either. It behaves more like something radiated outward, leaving behind information instead of pressure. At that point, scientists were no longer asking who made the image. They were asking something far more unsettling. What kind of process encodes distance, shape, and form, without contact, without pigment, and without distortion? Because when computers became powerful enough to analyze the image at the fiber level, they found something no human eye had ever seen. For decades, the limits weren't the cloth. They were the tools. Human eyes could only see so much. Even early computers lacked the power to separate signal from noise. That changed when artificial intelligence entered the picture. Researchers began feeding ultra-high-resolution scans of the shroud into neural networks designed to do one thing: find patterns no human would think to look for. The systems weren't told what the shroud was. They weren't given theology. They weren't given history. Only data. Millions of pixels, billions of comparisons, layer after layer of mathematical analysis. At first, nothing stood out. Then the AI flagged something unusual. Beneath the visible image, below the stains, the damage, and the weave of the linen, there was order, faint repeating structure, not in the shape of the man, not in the wounds, but embedded across the entire image like an invisible framework. The AI identified consistent geometric relationships, ratios that repeated across the face, hands, and torso. The spacing of the eyes, the length of the fingers, the curve of the ribs. Each measurement echoed the next, not artistically, mathematically. When researchers overlaid these ratios, the result was disturbing. The image aligned along a hidden geometric grid, one that no medieval artist could see, and no natural staining process should produce. the AI confirmed something else. The three-dimensional data wasn't approximate. It was precise. Each pixel followed the same rule. Brightness decreased in exact proportion to distance from the body. Not roughly, not symbolically. With mathematical consistency. When engineers tried to replicate this structure using random procedural generation, the results collapsed into noise. Millions of simulations failed. The probability of this kind of coherence appearing by chance dropped toward zero. And the deeper the AI analyzed the data, the stranger it became. Because these patterns weren't decorative, they behaved like a system, a highly organized dataset embedded into linen fibers just nanometers deep. At that point, the question changed again. If this wasn't art, and it wasn't contact, then whatever formed this image wasn't trying to show something, it was trying to encode something. And that realization opened the door to a possibility scientists had avoided for decades. What if the shroud isn't an image at all, but a record? Because when researchers treated the shroud like information instead of fabric, the data began pointing to an event, not a process. Once the shroud was treated as data, the numbers began to speak for themselves, and they were not subtle. Statisticians ran independent models to test a simple question. Could the patterns found by the AI emerge by chance? The answer came back the same every time. No. The level of order embedded in the image exceeded anything produced by randomness, artistic intent, or natural staining. The probability was not just low, it was vanishingly small. Less than 1 in trillions. That meant one thing. Whatever created the image did not happen slowly. It did not evolve over time, and it was not the result of repeated human action. It happened all at once, an event. The AI detected that the depth data across the entire body followed a single unified rule. Every pixel obeyed it, from the face to the feet. There were no corrections, no inconsistencies, no signs of adjustment. This was not trial and error. This was execution. If an artist had made a mistake, even a microscopic one, it would have shattered the geometry. But the structure held, which forced researchers to confront an unsettling implication. This image was not formed by contact. If it were, pressure would vary. The cloth would wrap and distort. The data would break. Instead, the image intensity weakened smoothly with distance, as if something passed through the space between the body and the cloth. Not touching it, not pressing it. A projection. And projections don't come from hands. They come from releases. Physicists began running models backward. If an energy source were responsible, it would need to act uniformly across an entire human form. Instantly, without heat damage, without penetration. The calculations were brutal. The energy would have to be intense enough to alter linen fibers at the molecular surface, yet controlled enough to stop within a few nanometers. Nothing in known medieval technology could do that. Nothing in modern technology can do it either. That realization unsettled even the skeptics, because if the image came from an event, then the shroud wasn't a depiction of death. It was a snapshot, a physical imprint left behind by something that happened once and never repeated. At this point, the debate stopped being historical. It became physical. What kind of event alters matter, encodes geometry, respects distance, and leaves no trace except information? Because when scientists calculated the energy required to form the image, the answer defied every known natural process. When scientists began calculating the energy required to form the shroud's image, the discussion changed tone. This was no longer about art, or symbolism, or belief. It was about physics. The AI models suggested that whatever formed the image acted faster than heat diffusion, faster than chemical reactions, and faster than any known biological process. The alteration of the linen fibers happened almost instantly. Physicists proposed several explanations. One idea was a powerful electrical discharge, a corona effect surrounding the body that could modify the surface of the cloth without burning it. Another theory pointed to a brief but intense burst of radiation, possibly ultraviolet light. Not continuous, not sustained. A pulse. Short enough to avoid scorching the fabric, yet strong enough to rearrange the molecular bonds on the surface of the linen. When researchers ran simulations, the results were disturbing. To create the shroud's image uniformly across a human-sized form would require an energy release so precise it bordered on impossible. Too weak and nothing happens. Too strong and the cloth is destroyed. Yet the shroud survived. The models showed the pulse would need to last less than a fraction of a second. Shorter than lightning. Shorter than most natural emissions. And it would need to originate from the body itself. That detail changed everything, because natural processes radiate outward unevenly. They flicker, they fluctuate. But the shroud's image showed no chaos, only order. Every region followed the same decay curve. Every fiber responded the same way. The energy didn't spread randomly. It obeyed a rule. That rule was so consistent that some physicists quietly admitted the image looked less like a burn and more like a controlled release. The implications were unsettling. Then reality itself may be far deeper than anything science has measured so far. The shroud remains sealed behind glass, silent, unchanged. But now, something has shifted. For centuries, faith asked humanity to believe without proof. Now, proof itself seems to be whispering back, not through doctrine, but through data. And one question refuses to go away. If this cloth recorded a moment when life passed through death, what happens when we finally understand how to read it completely? The shutdown came too late. In the days that followed, fragments of encrypted files began appearing in unexpected places: academic forums, private research networks, anonymous data drops, incomplete, unlabeled, but unmistakable. Researchers outside the original project recognized the signatures immediately. The geometry, the harmonics, the spatial decay curves. The shroud analysis had escaped containment. Within weeks, independent teams across the world began replicating parts of the findings. Not all of them succeeded. Most failed, but enough confirmed the same core anomaly. The structure was real, and it wasn't limited to belief. Physicists debated energy thresholds. Computer scientists argued over emergent behavior. Theologians watched in silence. The Vatican issued a brief statement. It acknowledged the ongoing research. It urged caution. It offered no conclusions. That silence spoke louder than words. Online, the reaction fractured. Some called it proof. Others called it pattern-seeking madness. But a new fear emerged beneath the arguments. What if the shroud wasn't unique? Amateur researchers began scanning other relics. Ancient burial cloths, icons, stone inscriptions. Most showed nothing, but a few produced faint echoes, incomplete geometry, broken harmonics, as if the shroud wasn't an anomaly, but a signal strong enough to survive time, and humanity was only now learning how to listen. Governments took notice. So did private labs. Funding shifted quietly. Projects changed names. Because the question was no longer religious. It was existential. If information can imprint itself onto matter, if events can leave structured echoes, then reality itself might be readable. And if it can be read, it can be searched. Because one final simulation would force a conclusion no one wanted to reach.